again start with the third chapter of plus 2, that is electrochemistry. When we are talking of electrochemistry, what is it? It is that branch of science in which electrical and chemical changes they are going to take place. So, branch of science which deals in electrical and chemical changes, that is what is electrochemistry, right? Now when we are talking of electrochemistry, we are going to talk of two types of cells. Because we are talking of electrical and chemical changes taking place, these changes they are taking place in certain, you can say, apparatus which is known as a cell. So under electrochemistry, we are going to study two types of cells. The first one that we are going to study is known as the electrochemical cell. In electrochemical cell, we say that chemical energy that is converted into electrical energy. Okay? That is what an electrochemical cell is. Now in this case, the chemical reactions which are taking place, reactions are spontaneous in nature. That is, the reactions they are going to take place on their own, as a result of which the flow of electrons will start and current will start flowing through the cell. The second type of cell which we are going to discuss in this chapter, that is the electrolytic cell. In electrolytic cell, an opposite process takes place than electrochemical cell. That is, over here, electrical energy is converted to chemical energy, right? And the reactions over here, the reactions are non-spontaneous. The reactions are non-spontaneous. In both the cells, as the electrons are going to flow, therefore we say that two types of reactions they are going to take place. One which is known as the oxidation reactions. Oxidation reaction means those reactions which are accompanied by loss of electrons, and reduction reactions which are accompanied by gain of electrons. Right? So simultaneously, as both the reactions they are going to take place, so we say that the basis of electrochemistry, that is going to be redox reactions, in which simultaneously both oxidation and reduction that is going to take place. Right? Now, obviously, when we are talking of flow of electricity or flow of current, we classify the substances into two types. One which is known as the insulators. We have done this in the first chapter. Insulators are those substances which do not conduct electricity, right? So substances are classified into two. The first which is known as insulators, and the second one which is known as conductors, right? Conductors are further classified into two. The first type of conductors, they are known as metallic conductors, and the second type of conductors, they are known as electrolytic conductors, right? So let's understand both type of conductors in detail. Let's go on to the first type of conductors which we will discuss. These conductors, they are known as metallic conductors, right? What are metallic conductors? Those conductors which conduct electricity by flow of electrons. They are known as metallic conductors, right? So these conductors, because they conduct electricity due to flow of electrons, these conductors, they are also known as electronic. They are also known as electronic conductors. In these type of conductors, the substances or metals conduct electricity without undergoing any chemical change. Without undergoing any chemical change. Which means that if we try to flow electricity through a metal, then what will happen? Electrons, they will get dislocated, they will start moving, they will start conducting electricity. But by looking at the metal, we do not see that any changes are taking place in the metal. Only the temperature of the metal that is going to increase. So when the temperature of the metal increases, it shows that it is conducting electricity. Otherwise, there is going to be no change in the structure or in the composition of the metal whatsoever. Okay, so over here, all the metallic conductors, they conduct electricity without undergoing any chemical change. Now, what are the substances or examples? All metals, they come under this category. For example, we are talking of aluminium, we are talking of iron, we are talking of copper. All these, they are going to conduct electricity. Then also non-metals. Non-metals like graphite, that also conducts electricity by flow of electrons. And then another example which we can take is that of alloys. There are certain alloys which are also conducting electricity by flow of electrons, so they are also known as what? They are known as metallic conductors. The second type of conductors which we have, they are known as electrolytic conductors. The electrolytic conductors, they conduct electricity by flow of ions. Therefore, these are also known as ionic conductors. In such conductors, the substances, they first dissociate into their respective ions and henceforth they start conducting electricity. Okay? So when we are talking of ionic conductors, we can say that electrolytic conductors conduct electricity by undergoing a chemical change. And what is the chemical change over here? The chemical change over here is that the metal, the substances, they are getting converted into ions. They are breaking into their ions. Okay? Then when we are talking of electrolytic conductors, they generally conduct electricity either in their aqueous states, in their solution forms, or aqueous state, or they conduct electricity in molten form. Okay, solid form will not conduct electricity. Why? Because the ions over there, they are not free. For example, when we are talking of sodium chloride when in solid form will not conduct electricity. It will only start conducting electricity when it is either melted or it is dissolved in water. ठीक है? So जो electrolytic है, they are going to conduct electricity only in the aqueous form. So these are the two types. Now electrolytic conductors, when we are talking of, we say that all substances which conduct electricity by movement of ions, they are known as electrolytes. So all substances which are conducting electricity by movement of ions, they are known as electrolytes. The electrolytes, they can be further divided into strong electrolytes, weak electrolytes, right? What are strong electrolytes? Strong electrolytes are those which completely dissociate right? So strong electrolytes are those which completely dissociate into their respective ions. So degree of dissociation for such electrolytes alpha, that is always equal to 1. Clear? 100% dissociation takes place for strong electrolytes. Examples which we can take over here is that of NaCl, KCl, HCl, H2SO4, etc. Whereas when we are talking of weak electrolytes do not completely dissociate. Right? So therefore, alpha for such, that is going to be always less than 1. Clear? And when we are talking of weak electrolytes, examples which we can take over here is that of acetic acid, HCl, sodium acetate, etc. Okay, so now we have done two types of conductors, metallic conductors and electrolytic conductors. When we want to point out the differences between the two, what are going to be the differences? Metallic conductors, they conduct electricity by flow of electrons. Electrolytic conductors, they conduct electricity by movement of ions. Over here in metallic conductors, the substances do not undergo any chemical change, whereas over here, they undergo certain chemical change to produce ions. Okay? Then in case of metallic conductors, there is no transfer of matter taking place. Okay? Because only electrons are moving, so matter does not there is no, you can say, exchange of matter which is taking place. But in electrolytic conductors, we shall see that there is certain transfer of matter taking place, which means that when we are talking of electrolytic conductors, we say that certain matter can be deposited at either of the electrodes, which we will do in detail in the next section, right? And then in this case, in metallic conductors, resistance increases, very important. Over here in metallic conductors, resistance increases with increase in temperature. So that means the conductivity that is going to decrease. Right? Whereas in electrolytic conductors, with increase in temperature, the resistance decreases. Therefore, with increase in temperature over here, the conductivity that is going to increase. Okay? Clear? Alright, so this is just an introduction to the chapter. We go on to the first type of cell, which is known as the electrolytic cell. Okay, so when we are talking of electrolytic cell, the process which is taking place in electrolytic cell, that process that is known as electrolysis. The electrolytic cell consists of one beaker in which the electrolyte that is taken. So in this beaker we are taking the electrolyte. We have already studied that the electrolyte should be either in the aqueous state or in the molten state, right? In this beaker, there are two electrodes placed. Electrodes are nothing but they are simple metal rods. Metal or non-metal can also be there. So these are the electrodes and they are connected to an external supply of current. Because in this we are going to give current from outside. Now when we are talking of electrodes, let's say electrodes may be of two kinds. Okay, the first kind, they are known as inert electrodes. What are inert electrodes? Inert electrodes only have or only is a support system which will allow the electrons to, or the ions to, or the current to pass from one electrode to the other. It will not react with the electrolyte at all. Okay? Examples of inert electrons which we can take, that is platinum, and mostly which we use is graphite. Clear? The second type of electrodes, they are known as reactive electrodes. The reactive electrodes are going to participate in the reaction. Okay, so generally the reactive electrodes which we use is copper or gold, right? And this reactive electrodes, they are used in a phenomenon which is known as electroplating. Okay, so in this case we need to take one pure electrode which is formed from a pure metal to put a film, or to, for example, if we are having these two electrodes, let's say this is the impure one and this is the pure one. Okay, so our main this thing is to put a film, or you can say electroplat a particular electrode. Okay, so if you're taking this as gold and we want to do electroplating of gold, then over here a film of gold would be casted, right? So this is what inert and reactive electrodes are. Now the electrodes, they are further of two types. The first type of electrodes, they are known as you can see there are two electrodes. So one electrode would be known as a cathode. Cathode is the electrode which is negatively charged. So if you are looking over here, this is the negative charge. So we say that this is the cathode. At cathode, always reduction is going to take place. That is, addition of electrons will take place at the cathode. The second type of electrode you can see over here, that is the anode. The anode is positively charged and at this electrode oxidation is going to take place. So this is the anode, right? Now in an electrolytic cell, because we are providing electricity from outside, the electrons will always flow from the anode to the cathode. Okay? So anode, that is going to, it is going to take the electrons from anode to the cathode. Flow of electrons will always take place in such manner. Because at anode oxidation is taking place, so oxidation is loss of electrons, it will lose electrons and cathode would attract those electrons towards itself. Okay? So this is what an electrolytic cell is. When we are talking of electrolytic cell, we have to know one very important theory which is known as preferential discharge. Preferential discharge theory. What do we understand by this theory? Sometimes what happens, like we have studied over here, there is a cathode and an anode, and two types of ions would be produced over here due to the dissociation of the electrolyte. The first type of ions, they are known as cations. The cations are positively charged, and the second type of ions, they are known as anions, which are negatively charged. Okay. The cations, they are attractive to the negative terminal, and the negative terminal is cathode. So cations get attracted towards the cathode and anions, they get attracted towards the anode. anodes. Sometimes what happens that in one particular electrolyte there are more than one ion present. Okay, so let's say that there are two cations present, right? Both the cations are positively charged. There is going to be race between the cations to run towards the cathode, but according to the preferential discharge theory, only those cations will be deposited on the cathode which have a lower value of discharge potential. This we will do in the electrochemical series also in detail, but right now you only have to know the theory. What does this theory say? You can write down. According to this theory, if more than one type of ions, if more than one type of ions are present and are attracted towards a particular electrode, then the one discharged is the ion which requires least energy. Right? Every ion has a different value of discharge potential. So the one which has a lower discharge potential, that is going to be deposited first. Let's take examples of electrolysis. The first example which we are going to take, the electrolysis of aqueous NaCl. Aqueous NaCl, right? Now aqueous NaCl means that we have dissolved NaCl in water. So NaCl that is going to dissociate as Na positive and Cl negative. Similarly, on passing current, water will also dissociate into H positive and OH negative. Although the dissociation over here is not too much, the more dissociation that is going to be of NaCl. Now when we are talking of reactions at the cathode, then what is happening over here? There are two positively charged ions, both are going to run towards the cathode. But we say that the discharge potential of H positive is less as with respect to Na positive. Therefore, in this H positive that is going to gain one electron to give us hydrogen. This is known as the primary reaction, and then the atomic hydrogens they combine together to give us a molecular hydrogen. This is the secondary reaction. Okay? Similarly, when we are talking of reaction at the anode. At anode also you can see that there are two negatively charged ions, OH negative and Cl negative. Okay? But over here the discharge potential of Cl negative is less. So we say that Cl negative is going to lose one electron to give us Cl, and chlorine plus chlorine enter into a secondary reaction to give us Cl2. Okay? Now what is left behind in the solution? Na positive is not getting discharged, OH negative is not getting discharged. So both these ions they remain in the solution. When we evaporate and crystallize the solution, right, we get crystals of sodium hydroxide. So what are we getting in NaOH? At cathode hydrogen is liberated, at anode chlorine is liberated, and in the solution what is left behind? Sodium and OH negative, Na positive and OH negative, that is there in the solution. Got it? Then the second one, the second electrolysis which we are going to do, that is of copper sulfate using platinum electrodes. Aqueous copper sulfate we are taking using platinum electrodes. Okay, so again let's say copper sulfate that is going to dissociate as Cu2 positive and SO4 2 negative. In a similar manner, H2O that is going to dissociate as H positive and OH negative. Okay. Now, when we are looking at the reaction of the cathode, we say that copper has a lower value of discharge potential. So, at cathode, Cu2 positive is going to gain 2 electrons to give us copper. Right? So, hydrogen will not be liberated over here, and at anode, the lower value is that of OH negative. Right? So, the reaction that is going to be 2 OH negative minus 2 electrons to give us H2O plus oxygen, and in the secondary reaction oxygen plus oxygen gives us O2. Right? So when we are talking of electrolysis of copper sulfate using platinum electrodes, then in that case copper is deposited at the cathode and oxygen will be liberated at the anode. Clear? Then let's take another example. The third example which we are going to take is that of aqueous solution of AgNO3. AgNO3. So in AgNO3 what is going to happen? AgNO3 dissociates into Ag positive plus NO3 negative, right? If we are taking aqueous solution, then water is also going to be there. It gives us H positive and OH negative. Okay, now over here also at the cathode, as silver has lower value of discharge potential, so silver is going to be deposited. Ag positive plus 1 electron to give us Ag. Right? And at anode, oxygen will be liberated due to the reaction of OH negative. So OH negative minus that is going to give us O2. Is it clear? Okay. Then we do another example. Electrolysis of copper sulfate using okay, now over here the reaction that is going to be different. Copper sulfate that dissociates to give us Cu2 positive plus SO4 2 negative. Now we are taking over here reactive electrodes of copper. So therefore the reaction at cathode, that is going to be a reduction reaction plus 2 electrons to give us copper. Okay? Whereas at anode a reverse reaction is going to take place, that is copper loses 2 electrons to give us Cu2 positive. Is it clear? So because we are taking reactive electrodes over here, so this is how the reaction that is going to take place. Now this process of electrolysis that is governed by a set of laws which are known as the Faraday's laws. Very important. Faraday was the scientist who first gave us an idea about charge. We have studied this in class 11. So he gave us the idea of charge. When we are talking of Faraday's laws, there are 2 laws of Faraday. Let's discuss the first law. According to the first law we have seen in electrolysis that there is certain amount of metal or certain amount of gas which is deposited and released at the cathode and the anode. The first law of Faraday that gives us an idea how much of the metal that will be deposited and how much of the gas would be released. According to the first law of Faraday, the weight of the substance deposited at the electrodes is directly proportional to Q. Okay, where W that is equal to weight of metal deposited and Q that is equal to charge flowing through the cell. Right? Now we know that Q that is equal to current flowing through the cell in specific amount of time, IT. So the above relation becomes W that is directly proportional to IT. Right? Or we can say that W that is equal to ZIT, where Z that is known as the electrochemical equivalent. Z is equal to electrochemical equivalent. So what is electrochemical equivalent? You can define electrochemical equivalent is the mass of the substance deposited when a current of 1 ampere flows through the cell in 1 second. Flows through the cell in 1 second. Okay. Now mathematically when we are talking of Z, then Z that is equal to weight or molecular mass or atomic mass upon N, where N is the number of electron exchange, into F, where F is 1 Faraday of electricity. So M over here, that is the atomic mass. N is equal to number of electron exchange, and F is equal to 1 Faraday of electricity, which is 96500 Coulomb. Putting the value of Z in the above equation, we get W that is equal to M upon NF into I into T. We can expect one numerical from this expression. Got it? Okay, so then we go on to the second law. According to the second law, if we are taking, you can say, different cells and they are connected in series. Okay, series ka matlab negative is connected to the positive of the next cell. So that is series. When we are talking of series, then we say that, and we are also saying that the same quantity of charge is flowing through the cell. Okay, then in that case, according to this law, equivalent mass of substance or metal 1 upon equivalent weight of substance 2. Equivalent weight of metal 1 upon equivalent weight of substance 2, that is equal to the mass of metal 1 deposited upon weight of substance 2 deposited. This is the second law, right? Let's take an example. We are taking 3 cells in series. 1, 2 and 3. Okay, so we have electrodes in this. We have placed 2 2 electrons in each of the cell, and then we are connecting them through a battery. So when we are connecting through a battery, this is the positive terminal and this is the negative terminal. But at the same time, you are also connecting each of the cells together. That is, this is going to be connected to this. If this is the positive terminal, then this is the negative terminal. Okay? Similarly, and this is the negative terminal. In the first beaker, we have taken H2SO4 solution. Second, we have taken copper sulfate solution, and in third, we have taken AgNO3 solution. Right? Now, according to the Faraday's law, according to the second law of Faraday, when we are looking at the first and the second cell, in the first cell hydrogen is going to be liberated and in the second cell copper is going to be liberated. Okay? So when we are looking at the first and the second cell, then mass of hydrogen upon mass of copper, right? Mass of hydrogen upon mass of copper, that is equivalent to equivalent weight of hydrogen upon equivalent weight of copper. Got it? Similarly, if we are talking of silver over here, silver and copper, then mass of copper upon mass of silver, that is going to be equal to equivalent weight of copper upon equivalent weight of silver. Got it? And we can also compare silver and hydrogen. So if you are taking silver and hydrogen, then mass of hydrogen upon mass of silver, that is equal to equivalent weight of hydrogen upon equivalent weight of silver. Okay? Have you understood? So this is the second law of Faraday. So today we will do only till here. Tomorrow we are going to do questions from this section and then we go on to the next topic. Okay?